Okay, guys, so welcome back. Okay, so I think in previous two session, actually I'm talking about like fundamentals of Python. Okay, so because I think you all know that this session. Okay, so this complete long 7 days boot camp is all about data analysis. Okay, so how we can make any kind of analysis on basically a particular data with the help of Python. Okay, so for that purpose, actually we need to use basically some kinds of a library which is available inside a Python. And but yes, for that purpose also you need basically some basic knowledge. Okay, so maybe if I consider that many of you have basically some basic knowledge or of basically Python, then also you need to basically refresh that knowledge. Okay, so for that purpose I just took two session on basically fundamentals of Python, and I try to cover all the basically essential things. Okay, so what are the essential components and what are the essential things which is required so that we can at a time when I'm trying to discuss about libraries, so there is no issue at all. Okay, so now I'm going to start with the library. Okay, so the very first library which is available inside a Python is nothing but a NumPy. Okay, so NumPy is basically the library which is available inside a Python. And definitely. So from today, your uh, actual data analysis part is going to start. So after the session, along with the recordings, I am definitely sending you this notebook to you guys. Okay, so I am sending you this notebook. So along with basically a recording. So below that recording session, this notebook is available also available to you guys. Okay, so don't worry about the notebook, but a very basic suggestion from my side. So if you try to do this thing along with me, so that thing is very is basically more helpful for you. Okay, so if you try to do along with me, so that is definitely help you guys. Okay, so NumPy means what? So NumPy is basically is designed for a scientific computation. Okay, and the full form of the full basically NumPy stands for a numerical Python. Okay, so numerical Python means any kind of a numerical operation, any advanced numerical operation. Okay, so not a basic numerical operation, because I think we can perform a basic numerical operation along with the core Python. Okay, so there is no need of basically any kind of a library, but advanced numerical operation. Okay, so advanced numerical operation, like if you want to do some calculation with array or with a matrix. Okay, or maybe anything, so at that point of a time you need basically a NumPy. Okay, so in our machine learning, actually what happens, so we have basically a data sets. Okay, so we have a data sets, and in our data set we definitely have basically a rows and columns. Okay, so and I think you know that in a matrix. Okay, so if you remember about a matrix, so what is matrix? So in a matrix also the elements are basically available in a form of a row and columns. Okay, so there is basically maybe more than 100 rows and more than 100 columns. And in a machine learning, you try to for making any kind of prediction, you need basically you are trying to perform a mathematical operations. Okay, so no prediction is prediction is not basically a kind of magic. Okay, so there is no magic behind it, that you just try to predict whether there is a rain tomorrow or not. Okay, so there is no magic behind it. Okay, so there is so for making this kind of prediction, you need some mathematical equation or need some mathematical operation. So for performing that kind of a mathematical equations or to compute basically a mathematical equation or operation, you need this kind of a libraries. Okay, so NumPy is not the only libraries. There are definitely other libraries which are also available. But yes, NumPy is basically you can say a basic and the first library which is available, through which you can basically perform which is designed for a scientific computation, and which is basically extends. This is a package to solve any multi-dimensional array. Okay, so any n-dimensional array, or you can say a multi-dimensional array, and it is also highly efficient. Okay, so NumPy is basically highly efficient. Fine. So for using a NumPy, so definitely it is not available inside a core Python. So you need to import NumPy. Okay, and you can call this NumPy with an alias name that is nothing but NP. Okay, so every time I don't want to write NumPy dot or so for performing any kind of operation, I don't want to write NumPy again and again and again. So for that purpose, I just try to import NumPy as NP. Okay, you can this is just an alias name, so you can basically call with any other name, but basically this is a standard name. Okay, so this is a standard name. So in most of the places and in everywhere, you can see that people are importing NumPy as NP. Okay, but definitely you can import NumPy as Shivam. You can import NumPy with your name, with my name. Okay, that is completely fine. Okay, fine. So now if I try, suppose if I try to create an array with the help of NumPy, so yes, I can create an array. So np dot array. Okay, so np dot array, and how I can basically create an array. Okay, so you just pass element which you are basically want to see inside an array in a list. Okay, now if you see the a, so a is nothing but a array. Okay, so array 3 4 5 6 7. So these are all the elements which is available inside this particular array. Okay, inside this particular array a. Fine. Now if I check the type of this a, okay, if I try to check the type of this basically a, so the type of a is nothing but a numpy. Okay, numpy dot nd array. So nd array means what? Nd array means n dimensional array. Okay, so the type of this a is nothing but a n dimensional array, np dot n dimensional array. And if I try to check the dimension, okay, so I think you all know what is the dimension of this array. So dimension means nothing that how many brackets are basically available. So the dimension of this array is nothing but if I try to check the dimension, so the dimension of this array is nothing but I think just one dimension. So this is a single dimensional array. So this ND, so it doesn't know that how many you can basically create any dimensional any number of dimension. So that is why it always return you the ND array, n dimensional array. But I think you all know that this is a single dimensional array. This is a simply a one dimensional array. Now if I want to check a shape of my basically array, so shape is nothing but 5 because you don't have any element in a column. Okay, you just have sorry, you don't have any you don't have you are not create any basically a matrix. You create a single array, single dimensional array. So in that there is basically no it will not come in a form of a row and column. Okay, so you get a shape as 5 cross 1. Okay, so 5 cross you can directly say that it is just a 5. Okay, so the shape of this array is nothing but a 5. Okay, so now if I try to check basically what are a different functionality. Okay, so this is basic things about basically NumPy. Now if I try to check some functionality which is available inside NumPy, so there is one thing which is called an upcasting. Okay, so suppose if I try to again create an array, so np dot array, and inside an np dot array, suppose if I try to create an array, and maybe okay, so in this way. Okay, so suppose if I try to, okay, so I think if I try to pass only an integer inside this array, but just I make maybe if I make one integer as a floating type integer. Okay, so maybe if I make it if I change its type. Okay, so inside an array I'm just trying to pass an integer, but if I try to change just type of just one element. Okay, so type of just one element, so what happens is, so if you try to basically run a again, so you can see that all the elements are basically become a float, all the integer elements is converted into a floating point numbers. Okay, so this concept is called basically a upcasting. Okay, so this concept is called upcasting. Fine. So this is called basically an upcasting. Now, okay. So now if I try to make maybe a two-dimensional array or maybe a three-dimensional array, so how I can try to build a two-dimensional array? So np dot array, and inside a np dot array I can write in this way. Okay, so for two-dimensional array I just basically try to create two braces. Okay, so two square bracket, and now if I yes, I can create a two-dimensional array in this way. Okay, so this is nothing but a two-dimensional array. Now, if I check basically a dimension of this array, so the dimension of this array is nothing but 2. And if I check the shape, okay, so I think now you can basically consider that shape is not basically going to the same, because this is available to me in a form of a row and column. Okay, so you are having a two row and three columns. Okay, so 2 cross 3, the shape of this basically array is nothing but a 2 cross 3. Okay, so in a same way, suppose if I yes, I can try to create a three-dimensional array maybe. Okay, so in a same way I can create a three-dimensional array. Okay, so suppose if I try to make just element to be same, that is not an issue definitely. Okay. Okay, so this is now basically your three-dimensional array. If you try to check a shape, so I think you all can basically tell me the shape of this array. So the shape is nothing but a 3 cross basically a 3. Okay, so in a three-dimensional array, so whenever you are basically trying to make a three-dimensional array, so it will try to tell you that it will try to basically tell you the size also. Okay, so it will try to tell you that how many basically a different array you are having. Okay, so how many different array you are having. So I think you are I am having just basically one and one basically array. Okay, so size is nothing but a 1, and I am creating a basic shape of this array is nothing but a 3 cross 3. Okay, so this is a shape of basically this particular array. Okay, so maybe if you are finding a difficulty to understand this, okay, so you can maybe try to make in this way. So let me take an example. Let me take another example so that you guys can understand. Okay, this is just the one is nothing but this is you are just trying to pass a single array. Okay, so you are trying to create this whole thing. So this is inside this basically a complete a big bracket. Okay, so a two double big bracket are here, and inside this two double big bracket these are the this is basically the whole your whole elements. Okay, so okay, so let me change this number. Okay, so suppose how basically this number is changes. Okay, so how I can basically make a kind of an array, create a kind of a matrix where you can basically find that this number becomes 2, or maybe this number becomes 3. Okay, in that way I think you are able to understand that why what is this basically 1 in this place. Okay, and definitely I think you are able to understand that this 3 cross 3 is nothing but a shape of my array. Okay, so I can create in this way. Okay, fine. And then if I try to basically, yeah, so this is a one bracket and a two bracket, and then if I try to make it this way. Okay, so 4, 7, and then maybe 8, 9. Okay, so I think now in this way, so this is again a three-dimensional array. Okay, so if you check the dimension, so this is nothing but a three-dimensional array. So 1, 2, and 3, and inside this three-dimensional array, you are trying to form basically two separate arrays. Okay, so two separate arrays are there, and if you trying to check basically shape of this array, so the shape of this array is nothing but a 2 x 2. Okay, so a shape of basically a single thing is nothing but a 2 x 2. Now if I try to run this C, okay, so now you can understand. Okay, so this is nothing but a three-dimensional array. Okay, so 1, 2, and 3, three-dimensional array, and there is basically a two array which is present inside this complete array. Okay, so and the dimension of each array is nothing but a 2 x 2. So if I try to check basically a shape, so now this time I get I think 2 x 2 and 2. Okay, so 2, because you are having basically a two matrix, two alone matrix, or two alone array, and then you are having a shape as okay, so 2 x 2. Fine. So in this way, you can create basically a single dimension, a one dimension, and a two dimension, and a three dimension array. Okay. Okay. So now I think this is clear to all of you. Now, if I basically just tell you about something else. Okay. So there is a very important concept which is available inside a Python, inside a NumPy, that is called a shallow copy and a deep copy. Okay, so shallow copy, deep copy. Okay, so now what is the difference between a shallow copy and a deep copy? Okay, and again, this is I must say this is a very important concept which is available inside NumPy. Okay, so what do you mean by a shallow copy? Okay, so suppose if I try to create an array inside an A. So np dot array, and if I just trying to pass maybe one array, okay, so 3, 4, 5, and 6 and 8. Okay, so fine. So 3, 4, 5, 6, and 8. These are all the elements which is available inside basically my array A. Fine. Now, if I do one thing, okay, so B is equals to A. Okay, so now if I basically try to do this thing, B is equals to A. So I just take basically one element, one variable B, and inside that variable B, I'm trying to basically assign a same thing which is available inside A. Okay, and so this method of copying basically element from one array to an another variable. Okay, so this method is called a solo copy. Okay, now try to understand that what is basically a main difference. Okay, so now if I check a B, okay, so B is having all the elements which is present inside a. Okay, so the elements inside A and the element present inside a B is basically the same. Now, suppose if I try to make one change, okay, so if maybe suppose if I try to make a change, okay, so on the first place, okay, so on the first place, maybe if I try to basically make this thing. Okay, so if I try to if I try to make a change, okay, so in place of a 4, okay, so suppose in place of a 4, okay, so I try to I can make it as maybe a 45. Okay, I can make it as a 45. Okay, fine. So how I can, yes, I can make it. Okay, so definitely there is no issue. Okay, so in place of 4. Okay, so now it becomes what? It becomes a 45. Okay, so 3, 45, 5, 6, and 8. And now suppose if I check A. Okay, so the same change is reflected in A also. Okay, so whatever the change I basically made in B, the same change is reflected inside A also. Okay, so this is this is the meaning of a shallow copy. Okay, so inside a shallow copy, so the change you are trying to make in a basically a new variable, the same change is reflected inside a old variable as well. Okay, because this both the okay so this because this both the variables are basically on the same address. Okay, so these both the variables are basically on the same address. So whatever the whatever the change you are trying to do in maybe a second variable, so the same change is basically reflected inside a first variable as well. Okay, in the original variable as well. Now if I try to make a deep copy, okay, so what do I mean by a deep copy? Okay, so C is equals to, suppose if I try to write a C is equals to np dot copy, and inside np dot copy, if I try to basically copy A, okay, so all the elements which is present inside a I am trying to copy in basically a C. Okay, so this method is called deep copy. Fine. So this method is called deep copy. Now, if I try to basically check the C, okay, so yes, now inside a C, we have basically the same element which is available inside a. Now, if I try to do the same thing with a C, okay, so which I am basically done with respect to B. Okay, so in place of a 45, okay, so in place of a 45, suppose if I want to make it as a 50, okay. So now if I check C, so yes, the change is basically reflected in C. But if I check A, okay, so A is not changed at all. Okay, so the same change is not reflected in A because this time, okay, so when I'm trying to use np dot copy, when I'm trying to perform a deep copy operation, so at that time, so the address of this both A and C is not same. Okay, so the address of this both the elements is not same because in np dot copy basically C is on some other location, okay, some on other location, and A is on basically some other location. Okay, so the address is not same, so that is why. Okay, someone asking me NP means. Okay, so NP means nothing, man. NP means just NP just an alias name for this NumPy. Okay, it is just an alias name for this NumPy. Okay, you can take any name. Okay, so you can you can take your name. You can take it as my name. Okay, anything. This is just an alias name. Okay, and for our simplicity, okay, because everywhere I don't want to use numpy. Okay, so just for my simplicity I just took alias name as np. Fine. Okay, so so I think in deep copy, so I think yes, you guys can see that this the same change, the change is not reflected in A. Okay, so why the change is not reflected in A? Because the address of basically both variable. Okay, so the address of in this place. Okay, when you're trying to use a copy function, so in this place the address of both the variables are basically not same. Okay, so the address is different. So yes, if the address is not same, so that change you are trying to do in maybe a new variable, so that change is not going to reflect in the original variable. Fine. So this is basically a meaning of what this is the meaning of a so this is the meaning of basically a deep copy. Fine. And someone asking me, okay, let me read the question again. So someone asking me why I need to import NumPy, what is there in that? Okay, so we need to import a NumPy, man, because NumPy is not available inside a core Python. Okay, so NumPy is a kind of a library. So whenever anything is not available inside a core Python, and whenever you are trying to use any kind of a library, so you need to import that library with basically that name. Okay, because NumPy is not available inside inside a core Python. Okay, so it is a kind of a library. So you need to basically import this library for using it. Fine. Okay. So this is about a shallow copy and a deep copy. Now, if I'm trying to basically take some another function, okay, so let's move forward and try to talk about maybe some another functions which is available inside NumPy. Okay, so there is one function which is available inside a NumPy which is called basically a from function. Okay, now in this from function, I think you need to use your basically knowledge of a lambda function, okay, which we have basically learned in yesterday's session. Okay, so numpy dot from function. Okay, so numpy dot from function means what? So I need to create, suppose I try to create basically a array, or I try to create maybe a matrix, and I try to create that matrix by using some function. Okay, by using some function, I'm trying to create maybe a matrix. Okay, so how I can construct that matrix, or how I can basically construct that array by using some function. So for that purpose, you can use np dot from function, np dot from function, and inside this I can basically use that particular function. Okay, so I think I already basically I already told you about inline function which is available inside a Python. So that is nothing but a lambda function. So by using a lambda operator or lambda, okay, so yes, you can basically create a function. So I try to create one function, and I try to basically construct an element based on this function itself. Okay, so how I can create it? So lambda ij, okay, so I have two elements I and j, and this I and j is nothing but a row and column. Okay, and I'm trying to basically create a function. So I equals to j. Okay, so if this happens, and then I'm trying to create a matrix of a 3 cross 3. Okay, so I'm trying to create a matrix of basically a 3 cross 3 by using this lambda function. And I also basically I also define that the type of the element which is present inside this matrix is nothing but a integer. Okay, so yes, this is fine. I think yes, I am able to basically print a statement. Okay, so you get basically array. Okay, so you get a matrix of 3 cross 3. Okay, so you already define the shape as 3 cross 3. So you get a matrix of 3 cross 3. I think you are able to see that you get basically you get a result in a form of a true and false. Okay, so true false false, then false true false, and then false false true. Okay, so I think it is a very easy thing, guys. You are able to understand that I and j is nothing but a row and columns. So wherever your basically a row is equals to your column. Okay, so suppose this is basically a row, so I, and this is basically a columns j. So I think you all know this thing. Okay, so if I try to create a matrix over here, and suppose I and j is nothing but a row and column. So row on this side, j on is this side. So this is basically a value. This is the index value. Okay, so a 0 is equals to 0. So wherever I equals to j, so yes, it is basically a true. And if 0 is not equals to 1, so yes, 0 is equals to 1. So this is not true, this is false. Okay, then again a false. Okay, then again false, and in this place again this is true, and this place is again this is true, and all these things are false. Okay, so this is the tech. This is basically a concept behind this matrix. Okay, which I am trying to create. Fine. So this is basically a use of a from function. So from function means you can define any kind of function. So maybe if I try to basically if I try to perform maybe a multiplication operation, or maybe if I try to perform addition operation. So yes, I can do that thing. Nobody is going to stop me. Okay, so suppose if I try to in this way. So I is equals to in place of I equals to j. If I try to write in this way. Okay, so yes, 0 cross 0, then 0 cross 1, then 0 cross 2, it will be 0 at all the place, then 1 cross 1, then 1 cross 2, and then a 2 cross 1, and then 2 cross 2. Okay, so yes, you are able to do this job. Okay, and yes, you can perform addition operation, or you can perform any kind of operation. There definitely no issue. Okay, maybe if you can also try to create a single dimensional array, or maybe a one dimensional array, and try to perform a square root. Okay, so try to get the square of each element which is present inside an array. Okay, so yes, you can also basically you can also perform this kind of a job, and for that purpose you can use in place of a from function, you can use a from iter. Okay, because you need to iterate. Okay, so you need to iterate basically over each element which is present inside an array. So you can use a from iter function. Okay, so there is one thing which is a from function inside a NumPy, and there is one thing which is called a from iter. Okay, so how you can basically use an iter operation? So iterable, maybe iterate, and you can write in this way. Okay, so I think you all know basically a program for creating a square. So x cross x for x in some range, maybe 6. Okay, fine. So just try to write in this way. So from iter. Okay, so in place of from function, I just try to write from iter, and then iterate, and maybe if I can also give basically data type. Okay, so yes, 0, 1, 4, 9, 16, and 25. Okay, so I'm able to basically get the square of each element from 0 to 5. Fine. Okay, now if I check basically another maybe a different kind of a function which is available inside a NumPy. Okay. Okay, so maybe so maybe if I can basically okay, so there is basically a different function which is available inside a NumPy. So that is nothing but a range function and a linspace function which is available. Okay, so range function and a linspace basically a function which is available inside a NumPy. Okay, so what do you mean by a range function, and what do you mean by a linspace function? And definitely you can also check what is the difference between, and with the help of a range function you can basically check two things. Okay, so I think there is basically a range function which is available inside core Python. Okay, and then there is a range function which is available inside a NumPy. Okay, so what is the difference between these two? Okay, so what is the difference between a range function, and what is the difference between a range and a range function? Okay, so suppose if I try to check that what is a difference between these two functions. So maybe if I try to basically use a range function. So range, I just define a range, and I think I told you that inside a range you need to give you need to provide basically three things. Okay, so the starting element, okay, then end element, and then basically your step size. Okay, so maybe I took a step size of 2. Okay, so yes, I'm able to basically print basically integer between 2 to 15 in with a step size of 2. Okay, so 2, 4, 6, 8, 10, 12, and 14. Fine. So yes, I'm able to get basically these numbers with the help of a range function. Now, if I try to basically do one thing, okay. So in place of a 2, maybe if in place of a 2, okay. So step size is my step size is 2. Suppose if I try to make this step size as 2.5, okay. So if I try to make this step size 2.5, so I am getting an error. Okay, so it told me that float object cannot be interpreted as an integer. So it means what? It means that in a range function, inside a range function, you can only pass a basically an integer value, not a floating point number. So okay, anywhere like if your starting value, your end value, and your step size all these three basically values should must be an integer. Okay, so they can't be an they definitely can't be an basically a floating point number. They must be an integer. Okay, so suppose so they can't be an integer, as I told you. So so now in a range function, okay, so this is the implementation of a range function. Okay, so this is the advancement of a range function. So that in a range function you can pass a floating point number at anywhere. Okay, so not just in not basically in a range function. So if I write in this way, so np dot a range function. Okay, so yes, I am able to print this. Okay, so at 2, then 4.5, then 7, and then 9.5, then 12, and then 14.5. Okay, so yes, I am able to basically print this element, and the step size is what? The step size is nothing but a 2.5. Fine. So this is basically an improvement inside a range function in comparison to a range function which is available inside a core Python. Okay, and definitely you can any element. Okay, so starting number and an end number, or maybe a step size, or any number can be definitely any number can be decimal. Okay, so there is no restriction. Fine. And now with this thing, with a range and a range function, because range function belongs to a core Python, and a range function is belongs to a basically your NumPy library. So in this way, I can basically I can told you one more thing. Okay, so I can show you one more thing. Okay, so why we can say that NumPy is an efficient. Okay, so in comparison to a core Python, in comparison to a list, NumPy is more efficient. Okay, so somebody asked me a question. Let me check what is the question. If we want to perform mathematical calculation in data frame or array NumPy, we import NumPy. What do you mean by this? Try to reframe your question. Yeah, you can perform NumPy. No, I think maybe you miss maybe a first class. So in a first class, I told you that a basic numerical operation you can basically you can do with a core Python also. Okay, so within a core Python you can do a basic calculations. Okay, but for performing an advanced calculation or advanced mathematical operation, or maybe when you want to deal with the array or a multi-dimensional array, so at that time you need basically a NumPy library. Okay. Okay. Now, if I try to basically show you that why I basically say this thing again and again, that NumPy is more efficient. Okay. So suppose I try to basically create a simple program with a range function. Okay, so L is equals to a range of 1,000. Okay, so I just try to create a list maybe, and I try to basically check timing. Okay, so then inside this, I just try to show you that how much time basically a range function take to implement something, and how much time basically a range function take for I in L. Okay, so I modulus 2 for I in L. Okay, so means I just try to create a kind of a program where I try to basically print I modulus 2 means any element. Okay, so any element which is divisible by 2. Yes, I am trying to print those elements. Okay, I am trying to put those elements, or maybe I can do another job. Okay, so that is more fundamental. Okay, so I try to perform a square. I try to do a square of each and every element which is available inside this range. Okay, so in a range of 1,000. Okay, so from starting 1 to 1,000, I'm trying to perform a square operation. Okay, I'm trying to perform a square operation which each and every element in between the range of 1 to 1,000. Okay, so and I just try to check the time. Okay, so how many times basically it will take to give me the result. Okay, so I'm not here basically getting any basically output, the square of each and every element. I just get basically how many times it takes. Okay, so it takes 1.25 millisecond plus minus 205 millisecond per loop. Okay, so mean plus minus a standard deviation, that is. Okay, so I think we are not talked about, we are not discuss about maybe loop, okay, maybe a mean and standard deviation, but I think you guys can know the definition, or you guys I think better know the definition of a mean and standard deviation. Okay, so mean is basically average of your data set, and so this is average time it will take, and this is a standard deviation. Okay, so how many fluctuations? So 1.25 plus minus 205. Okay, so 1.25 plus 205 microsecond it can take. Okay, and this is a millisecond. Okay, so this is not a microsecond. Okay, so this is a more basically a lesser unit. Okay, so a microsecond. Now if I check, if I try to do the same thing with a range function. Okay, so just try to basically do this thing with the a range function. So if I can write a equals to np dot a range, and I just try to give the same range 1000, and now if I try to basically do this operation, so a, fine. So just try to check how much time basically it will take to give you the basically result. Okay, so it will take a 6.21 microsecond. Okay, so just try to see that. Okay, so it will take us millisecond. Okay, not microsecond. Okay, so millisecond is basically a higher parameter. Okay, so it takes a 1.25 millisecond. Okay, maybe if it gives me the result in microsecond, then it is basically easier for you to make a comparison. Okay, so I just hope that it can give me the result. Okay, so again it give me a result in basically a millisecond. Okay, so that is not an issue. Okay, fine. So millisecond means it is just maybe you can consider it as a 133. Okay, so maybe you can multiply this thing with 100, so it is nothing but a 133. So it is basically a huge difference between in terms of a timing. Okay, so in terms of a timing there is a huge difference between a range and a range function. Okay, so that is why people are basically say that a NumPy is more efficient in comparison to a core Python. Okay, so NumPy library is basically a more efficient in comparison to a core Python. Now, if I talk about basically another function, which is nothing but a lean space. Oh, I don't want to mark down this. Okay, so now if I talk about a lean space function. Okay, so what do you mean by a lean space function? Okay, so suppose if I try to basically create a lean, try to maybe print something with the help of a lean space, and I think you guys can understand by yourself also that what is basic, what are basically things we are getting inside a lean space. Okay, so inside a lean space, again you need to provide maybe a same thing. Okay, so one, okay, so starting number and then the end number, and then there is something which is a total number of points. Okay, so you are trying to print a 20 numbers. Okay, so linear space means what? If I try to run this program, so you can see that you are trying to print a 20 numbers between 1 and 5. Okay, so between 1 and 5, it tries to basically divide each number. It will try to divide in equal part. Okay, so you can see this thing also. So 1.21, then the next number is what? 1.42. Okay, so 0.21 is basically that value through which it is able to divide. Okay, and you can also check that basically step. Okay, so what are basically value which is with which it is trying to divide. Okay, so there is one thing which is available inside this, that is a ret step. Okay, so the ret step is false by default. If I try to make this true, now, yes, you are able to see that basically the value through which it is trying to divide. Okay, so linear space to what? It is trying to print basically a 20 elements. Okay, and whatever element. Okay, so you can give in place of 20, you can give 10, you can give basically a 30, you can give 40. Okay, so based on your choice. Okay, it is definitely based on your choice. Nobody is going to basically ask you. It is based on your choice. So between 1 to 5, you are trying to basically print 20 numbers. Fine, with the help of a linspace. Now, so this is the purpose of basically a linspace. I think you guys can understand. So now if I try to basically create some basically common arrays, okay. So if I try to basically create a some common arrays, so how I can basically create maybe a some common arrays, and what are basically that common arrays? Okay, so there are definitely different kinds of arrays which are available inside a NumPy. Okay, so suppose in this way, so np dot zeros. Okay, so np dot zeros. So np dot zeros means what? You are trying to create. You just try to you can you can or you just trying to pass a shape of that array. Okay, so the shape of my array is what? The shape of my array is nothing but a 3 cross 3, and I'm trying to create a matrix of 3 cross 3 where each element is what? Where each element is 0. Okay. So and you can create basically a zero element array of maybe any and the shape of the matrix can be anything. Okay, so it can be a 4 cross 4, it can be a 3 cross 4, it can be a 3 cross 5, anything. Fine. In the same way, you can create basically okay, guys. There's small basically issue with the internet connectivity. Fine. Okay, so just let me confirm. Okay, so anyone that now it is okay. My screen is visible to you and my voice is audible. Okay, so the guys from my side. Okay, so you can confirm this thing in a chat box. So voice is clear. Okay, okay, okay. Fine, guys. Thank you. So np.i. So np.i means what? You are trying to create basically what you are trying to create a diagonal array. Okay, so you are trying to create a diagonal matrix. Okay, so I think you all know that what do you mean by a diagonal matrix. So diagonal matrix means in or basically you are I means what you are trying to sorry not a diagonal matrix, so it's my bad. Okay, so that it means I means identity matrix. Okay, so in an identity matrix your diagonal element is basically 1 and all the other elements basically a 0. Okay, so this is what this is called a identity matrix. Okay, so with the help of np.i you are able to create what? You are able to create a identity matrix. Fine. Now, if I try to create if I try to generate a random numbers, okay. So suppose if I can try to create a random numbers, okay. So how I can basically generate the random numbers with the help of a NumPy. So I can create a random number in maybe a 3 ways, and there are basically yeah, there are multiple ways. Okay, so suppose if I try to basically create a random numbers, so R1, so np dot random dot ran. Okay, so with the help of np.random.rand, I can basically I can create a matrix. Okay, I can create a matrix, and I just need to with the random numbers. Okay, so with the random numbers. Okay, so and I just need to provide my the shape of the matrix. Okay, so what is the what shape I want? Okay, so maybe a 4 cross 3. Now, if I run this R1, okay, so yes, I am getting basically a matrix of a random numbers. Okay, so these are all the random numbers which is available inside basically this R1 matrix, and the shape of my R1 is nothing but a 4 cross 3. Now, if I again run this, so the values are changes. Okay, because these are all the random numbers. Fine. This is basically a random numbers, and there is one more way to create a random numbers. And that random, again we get a random number in a decimal values. Okay, but there is a thin difference between these two. Okay, so maybe if I try to create, so np.random.randn and then R2. Okay, so you can definitely visualize basically a thin difference between these two creation. Okay, so in this place, okay, so in this place with the help of np.random.rand, okay, so the difference between these two basically creation of a random numbers is a statistical difference. Okay, so if you have any statistical knowledge, or maybe if you have any knowledge of maybe a probability distribution, so you can definitely visualize this difference. But as for now, if you don't know, so just try to consider that this values is come from this particular values is come from a uniform distribution. Okay, so in a probability distribution function there is a different kind of a distributions available. Okay, so this values these all the values are come from a uniform distribution. Okay, so inside a np.random.rand, okay, so when we are trying to create a basically when we are trying to generate a random numbers with the help of np.random.rand, so these values are come from a basically from a uniform distribution, and here all these values are come from a standard normal distribution. Okay, standard normal distribution. Okay, so this is basically a difference between these two kind of random value generation. Okay, so when we are trying to generate a random numbers with the help of a NumPy, so we can create a random numbers, and in the both the place you can see that in both the way I can create a random numbers, but I can create a random numbers of and all these numbers are basically a decimals. Okay, so I'm not able to create integer numbers. Okay, so I'm not able to create I am not able to generate a random numbers, random integer numbers. Okay, so fine, that is fine. Yes, with the help of rand and with the help of rand, and I am able to generate a random numbers, decimal random numbers, floating point random numbers. Now, how I can basically generate integer random numbers with the help of a NumPy? Okay, so yes, I can generate. Okay, so with the help of np dot random dot rand int. Okay, so np dot random dot rand int. Okay, so with the help of np dot random dot rand int, I can create a random numbers. I can generate a random numbers. I can generate a integer random numbers. Okay, but the prototype is different. Okay, so the prototype is different in comparison to rand and rand n. Okay, so you need to provide basically a range. Okay, so in which range you want so what is the range of your integers? Okay, so maybe if I try to create a random numbers between 1 to 50, if I try to generate a random numbers between 1 to 50, and then in this place I need to provide a shape of basically a matrix. Okay, so what is the shape of my matrix? Okay, so suppose I try to I try to basically take a shape of 5 cross 4. Okay, so yes, I'm able to create a random numbers. Okay, so my random number is between 1 to 50, and the shape of my array is nothing but a 5 cross 4. Fine. So this is basically a way in which you can basically generate a random numbers. Okay, so these are basically a basic ways in which you can create what you can create a random numbers. Fine, guys, so I think this is a simplest this is the simplest thing which you can basically do. Now if I try to I try to basically show you, or if I try to basically uh, tell you some more functionality which is available inside of Python. Okay, so there is one more important concept, just like a deep copy and a shallow copy, which is called a Boolean masking. Okay, so or you can simply say it as a masking. Okay, so a masking and a Boolean masking is maybe a two different thing. Okay, so suppose if I try to basically show you that what is a Boolean masking. Okay, so suppose in this place I try to basically create an array, or I try to generate a random number matrix. So I already have one, so I can create in this way. So R4, and then I just try to take a shape of maybe in this way, a 4 cross 4. Fine. Okay. Now if I try to write in this way, so R4. Okay, so this is known as masking. So R4 or maybe a Boolean, this is known as basically a Boolean masking. So if I try to write R4 is greater than what R4 is greater than, okay, so most of the number is basically fine. So I can write it as 30. Okay, so this is what we call a Boolean masking. Okay, because I am getting a bool in this array, and now you guys can identify, or you guys can basically visualize this thing, that where I am getting true and where I am getting false. Okay, so wherever my value is greater than basically a 13, so at that time I am getting true, and wherever my value is lesser than 13, so I am getting false. Fine. And so this is what we call a Boolean. Okay, what we call a Boolean masking. And now if I try to get only those values which are greater than 13. Okay, so how I can basically access only those values which are greater than 13. So yes, I can access in this way. Okay, so yes, I am having a 14, 14, 16, 19, and 17. So these are all the numbers which are basically greater than 13 inside this array, inside this R4, basically inside this matrix, whose name is nothing but a R4. Fine. So I think this is basic. Everyone is able to understand this thing. Now, if I choose another basically a problem. Okay, so now if I try to show you the another concept. Okay, so another concept which I can basically discuss with you guys is nothing but a reshaping operation. Okay, so reshaping operation. So what I mean by a reshaping operation, so maybe if I try to print R5, okay. So reshaping means what? So my shape of my matrix is the shape of my matrix is nothing but a 5 cross 4. Okay. So this reshaping operation is basically very necessary, and you might basically face this kind of an issue when you are trying to solve basically a machine learning problem statement. So you guys can face this kind of issue where you need to reshape your matrix. Okay, where you need to reshape your data. Okay, so how you can basically reshape your data? Okay, so maybe in place of a 5 cross 4. Okay, and just remember one thing: you can't basically reshape your data in another size. Okay, so 5 cross 4 means the size of this matrix is nothing but a 20. Okay, so 5 cross 4 is equal to 20. Okay, so you can't basically reshape your matrix lesser than 20. Okay, so wherever the size is lesser than 20 and not more than 20. Okay, so you can reshape it. Okay, so you can reshape it, but the size can't be altered. Okay, so how I can basically reshape this thing? Okay, so maybe I can reshape in this way. Okay, so just a 20 cross 1. Fine. Yes, I'm able to do this. Maybe I can do maybe I can do this thing also. A 10 cross 2. Yes, I'm able to do this. Yeah, reshape, not a shape. Yeah, I'm able to do this. Okay, maybe if you can also write in place of maybe a 5 cross 4, you can write a 4 cross 5. That is also possible. There is no issue. Okay, so in place of 5 cross 4, I can write it as a 4 cross 5. But if I try maybe anything else, okay, so where there is a possibility that my size, the size of my array can be altered, so that is not possible. So that gives me an error. Okay, so if I try this thing, okay, so reshape, and in this place if I try to write in this way 4 cross 3, okay, so it give me an error because and it gives me an error, so it tells me that cannot reshape array of size 20 into shape 4 cross 3, because if we try to multiply 4 cross 3, so that is equals to 12. Okay, but the size of my original array is what? The size of my original array is nothing but a 20. Okay, so fine guys, I think yes, till this point everyone of you is able to understand. Now, yes, so I just take a 30 seconds of a break. So if anyone have any query, so you guys can ask me. Okay, guys. Okay. So I think nobody have any issue. So that is good. That is fine for me. Okay, now if I basically talk about some mathematical operations. Okay, so if I talk about maybe some mathematical operations, that how you can basically perform any kind of a mathematical operation with a basically array along with a NumPy. Okay, so array math. Okay, so suppose if I try to create maybe a two array. Okay, so on the way. Okay, so someone how can we multiply a 3D matrix? Okay, so a three-dimensional matrix. You want to multiply maybe a three-dimension matrix. Okay, fine. So yes, I'm starting that thing only. Okay, so in an array math. Okay, so maybe if I trying to create two arrays. Okay, so np dot array. So in the same way, okay, so in the same way, so you asked me a question that how you can basically multiply a three-dimensional array. So in the same way in which you are trying to multiply maybe a two-dimensional array in this place, which I'm going to tell you. So in the same way, you can basically multiply a three-dimensional array. So don't worry, I come on to that point. Okay, so 2 comma 3 and then maybe a 5 comma 6. Okay, so this is maybe my this is one array, and then inside a y I can create maybe another array. Okay, so my x is this and my y is this. Now if I try to perform any maybe a mathematical operation, so I can basically try to perform in this way. So x plus y. Yes, so I'm able to get the addition of basically a two matrix. So 2 plus 5 is 7, 3 plus 6 is 9. Okay, so this is a simple addition operation we can do with the basically inside an array, and I can also perform in this way. Okay, so np dot array and sorry, np dot add. Okay, so np dot add, and I can pass my basically to array. Okay, so I'm getting the same result. Okay, so I'm getting the same result whether I'm trying to basically perform, I'm just trying to use a simple operation in between two operand, or if I use just np dot add. Okay, so in the same way you can basically perform a subtraction or operation with the help of np dot subtract. Okay, so with the help of np dot subtract you can basically perform a subtraction operation also, and then if I try to perform a multiplication operation, x into y. Okay, so with the help of x into y means with the help of uh, multiplication operation, you can perform this thing. Okay, so x into y. Okay, fine. So you are getting some kind of a result. Okay, so you are getting some kind of a result by performing x into y. So 2 into 5 is 10, then 3 into 6 is 18, and then 4 into what? So 4 into 5 is 20, and then 6 into 7 is 42. But this is, remember guys, so this is just element-wise multiplication. Okay, so this is what? This is an element-wise multiplication. And if I try to perform this thing, okay, so np dot multiply, and if I'm passing x comma y, okay, so I'm getting the same result. Okay, so this is what? This is basically element wise multiplication. This is not a matrix multiplication. Okay, so I think if you guys remember a matrix multiplication, so that is different. Okay, so someone asked, okay, let me zoom. Okay, so sir, in attendance form, it shows like you already responded. Is it okay to just edit the form? Yes, sir. Yeah, sir. It is fine. I guess no need to fill again. It's for, yeah, it is for only one time. Okay, okay, guys. I think that someone asking a question related to NumPy. Okay, guys. Okay, I think we come on to this discussion after basically after the class is over. Okay, so don't worry. And yes, someone I think Shivam, maybe Shivam basically write correct answer. Okay, so if you fill the form once, so don't need to fill it maybe again. Okay, so that is completely fine. That is only for a certification. Okay, so and I also remember who is basically trying to do take a class regularly. Okay, I think maybe I remember 3 4 names. Okay, so don't worry guys. Okay, so np dot multiply. So with the help of np dot multiply and with the help of x cross y, you are able to perform what? You are able to perform element wise multiplication. Okay, so you are not able to perform a matrix multiplication. Okay, so I think if you remember what do you mean, what I mean by a element wise what I mean by a matrix multiplication. So I think if I can show you. Okay, so I just use that annotation. Okay, so right now what you are basically doing, so x and y, maybe this is your two array. So 1, 2, 3, and 4, G1, 0, 2, and 1. Maybe this is a matrix. Okay, so for now you are trying to perform a element wise multiplication. So 1 cross 1, then 2 cross 0, then 3 cross 2, and then 4 cross 1. Okay, so and you are getting a result. But this is not a matrix multiplication. I think if you remember, so this is not basically a matrix multiplication. In a matrix multiplication, you can do something like this. Okay, so 1 cross 1, and then 2 cross 2 is basically 1 cross 1 is 1, and then 2 cross 2 is 4. So you are getting a 5 in this place. Now I perform the same thing with this. Okay, so this is what we call a matrix multiplication. Okay, so I think now you guys basically can remember that what I mean by a matrix multiplication. Okay, so 1 cross 0, and then 1 cross 1, 1 plus 2. Okay, so that is 3. Then in same way you are trying to perform here, and then in the same way you are trying to perform here. So 3 cross 1 is 3, and then 4 cross 8 plus 3 is 11, and then 4 cross basically 1 is 4. Fine. So this is what basically this is what we call a matrix multiplication. But here, I think in this case, when we are trying to perform a np dot multiply, and we are trying to multiply x and y, so you are getting element wise multiplication. Okay, so a 2 cross basically 5. Okay, that is 10. Now, if I trying to perform how I can basically perform a matrix multiplication. So for performing a matrix multiplication, you did not worry about so much. You can perform in 2 ways. Okay, so you can write x at the rate y. So in this way, you can perform a matrix multiplication. Okay, now this is a matrix multiplication, and now you can basically compare the result is different. Okay, and this is basically okay. So let me once print x and y again. Okay, so if now you guys can basically perform a matrix multiplication, just try to get one result and then try to compare whether your result is correct or not. Okay, so this is what we call a matrix multiplication. So with the help of this at the rate operation, you can perform a matrix multiplication. And there is one more operation. So np dot dot. Okay, so with the help of np dot dot, you can perform a matrix multiplication. Okay, so you can compare the both the results are basically the same. Fine. So this is called a matrix multiplication. I think I can write this thing inside comments so that this thing can help guys. Okay, so matrix multiplication. Don't worry, I will basically share this notebook with you guys along with the proper comments and a proper markdown. So maybe by adding maybe some more functions and features, and so that will definitely help you guys in future also. Okay. And what are the other kind of a mathematical operation I can perform? So yes, I can definitely divide basically two arrays. So x divided by y. So for that purpose, I can directly use a dividend operator. Okay, so x divided by y, and I can also write np dot divide. Okay, and I can also perform basically a square root. Okay, so I can also find a square root of maybe an array. So np dot sqrt. Okay, so np dot sqrt. Okay, I can also find a log of basically this thing. Okay, so the log of maybe a log of base 10, log of base e, a log of base 2. Okay, so yes, I'm getting basically an output of log. Okay, so these are all the function. These are all the basically mathematical operation I can perform. Yes, and a many more. Okay, and many more like if I can also get a modulus. Okay, so np dot f mode. Okay, so yes, I am able to get the modulus. Fine guys. So and there is so many mathematical operation, and you can try to check this thing with the maybe if any function basically comes in your mind. Okay, so if any function comes in your mind, so you can press the basically tab button after maybe writing one thing. Okay, so if I just remind that there is something called an exponential. Okay, so whether exponential operation is present inside a numpy or not. Okay, so yes, exponential operation is present. Okay, so yes, you can perform an exponential operation. Fine. So I think now you guys can understand that what are the different kinds of mathematical operation you can perform along with the NumPy. Now I just need to tell you one more important thing along with the row and columns. Okay, so maybe if I try to create an array in this way, so 2 comma 3 and then 4 comma 5. So this is my x. Okay, this is my x. This is my two-dimensional array. Now, if I try to find out basically sum of this thing. Okay, so np dot sum. Okay, so np dot sum. If I try to basically get the sum of this array, so I am getting a what I'm getting a 14. So 2 plus 3 is nothing but 5. 5 plus 5 10, and plus 4 is 14. Now, if I try to basically get only a column sum, or maybe if I try to print only the row sum, okay. So for getting only a column sum, okay, so for basically a column, you need to give axis as equals to 1. Okay, so there is something is called axis. Okay, so axis is basically a different. So axis is very important concept. Okay, so in machine learning also, most of the time you are trying to drop basically maybe some columns. Okay, so in the next class in a pandas, maybe I took a real live data set. Okay, so in that real live data set, I can basically use an axis columns. Okay, I can and in a pandas there is a function available which is called a drop function. So with the help of a drop function, I can drop maybe any column or maybe any row which is not basically important for me, which is irrelevant. Okay, so in that case, this axis concept is very important. Okay, so axis is equals to 1 means what? Axis is equals to 1 means a row. Okay, so if you want a row wise summation, okay, so in that place you can basically give axis as equals to 1. Okay, so I am getting a 5 and 9. Okay, so a row wise means what? So 2 plus 3 is 5, and then 4 plus 5 is 9. Okay, so yes, you are able to perform a row wise basically a summation. Now if I'm basically trying to perform what? If I'm trying to perform a column wise summation. Okay, so in that place you just need to change your axis. Okay, so axis is equals to what? Axis is equals to 0. I again give access. Okay, so 6 8. So 2 plus 4 is basically a 6, and 3 plus 5 is nothing but a 8. Okay, guys. So this is this concept, this axis concept, is very important. So only for that purpose, I basically took this summation operation. And definitely don't worry, guys. I just write this thing in a comment. Okay, so if I try to write each and every comment, so it will take a lot of time. So I just write a comment, and then while basically uploading this, when I'm trying to when I'm going to upload this recording, so at the same time I upload basically this notebook with okay, so making up proper comments and markdowns. Okay, now if I try to basically perform a broadcasting, okay, so there is one more important concept inside NumPy, which is called a broadcasting operation. Okay, so what do you mean by a broadcasting operation, and what is meaning of broadcasting? Okay, so suppose I just try to create an array. S is equals to np dot maybe a zeros. And this is again a very simple concept. The name is only maybe I can say a fancy, but the concept is very simple. Okay, so I'm able to get this array, and I think everyone expected the same thing. Okay, with the help of np.zeros. Now, if I try to perform maybe one operation, so s plus 100. Okay, so this is what we call a broadcasting. Okay, so s plus 100. Okay, so if I'm trying to apply s plus 100, so what basically what is my result? Okay, so s is my matrix, and now it basically it changes. Okay, so in place of 0, everywhere I get what I get 100. Okay, so it means what? So this is a meaning of a broadcasting. Okay, so you are trying to broadcast basically one operation, or you are trying to broadcast one element on basically on your whole data set, on your whole basically a matrix. Okay, so with the help of s plus 100, so so 100 is going to basically add all the elements. Okay, so it is just an element wise addition, so I am able to perform an element wise addition with all the elements which is available inside this matrix. Fine. Now, suppose, okay, so there is, I can basically perform a broadcasting operation in a two ways. Okay, so I can perform a row-wise broadcasting, and I can also perform a column-wise broadcasting. Okay, so how I can basically perform a row-wise broadcasting, and how I can perform a column-wise broadcasting. So a dot rows, maybe if I can write in this way, and then I just try to create an array. So I think I am having a same number of row, and I am having a same number of columns, so there is no confusion. So so my array size should be basically a 4. So maybe a 3, 2, 4, and 1. Okay. So 3, 2, 4, and 1, and now I try to basically add this element row wise. Okay, row wise means what? So with 100. Okay, so in this way. Okay, so in a horizontal, okay, so in a horizontal way, I am able to basically add these numbers. Okay, so 103, then 102, then 104, then 101, and then the repetition. Okay, so again 103, again 102, 104, and 101. Okay, so horizontal wise basically addition I am able to do with this. Okay, so this is my assumption. Okay, so this is my assumption, and for before that, because this is not changed. Now, if I took my s, okay, so this is fine. S is equal to 100. Now, I check another variable. So here I can use this thing. Okay, so s plus basically a underscore rows. Now if I check wise, okay, so yes, I am able to perform a row wise addition. Okay, so horizontal addition I am able to perform. This is called a row wise broadcasting. Okay, so this is what this is just a row wise broadcasting. Okay, now if I try to perform a column wise broadcasting, okay, so in this way, in a vertical way. Okay, so how I can basically do a column wise broadcasting? Okay, so okay, just try to observe those things. Okay, so a false, and again I'm trying to basically create an array, and p dot array, and now I am trying to perform what? I am trying to do a column wise broadcasting, 2 5 6 and 1. Okay, so but my equals is basically in a horizontal axis. So how I can basically change its direction? Okay, so again, if I am trying to with the name, it is not going to acceptable because the name is given by us only. Okay, so whether I am using a rows or whether I am using a column, so it is going to perform in the same way if I'm not basically changing its type. Okay, so I can do one thing. Okay, so there is one operation which is present inside a NumPy that is nothing but a transpose operation. Okay, so with T it is not able to transpose. Maybe if I took a transpose. Okay, okay, it is not basically able to transpose. Let's try to do one thing. Okay, because for doing a transportation, it should be 2D array. Yes. Now I am able to transpose. Okay, so now it is going to basically I am able to add this thing column wise. Okay, so now I am able to add this thing column wise, maybe in a vertical direction. Okay, so I think you already know about a Y. Okay, but I'm trying to add this thing in a S. Okay, so S is 100. So I'm getting result in this way. Okay, so 102, then 105, then 106, then 101, and again this thing is repeating vertically. Okay, so not horizontally. This thing is repeated. This thing is going to basically repeated vertically. Okay, so S plus A equals. Fine. So I am getting basically this is what we call a column wise broadcasting. This is not a row wise broadcasting. This is just a column wise broadcasting. Fine, guys. So I think yes, you guys can understand meaning of a broadcasting. Okay, and again, the broadcasting is okay. So maybe it is a simpler thing for you, and definitely it is not a very big deal to basically learn about the broadcasting, but it is but also it is but then also it is a very important concept inside a NumPy. Okay, so it is one of the you can say a most important concept which is available inside a NumPy. Fine. So and then okay, so there is another maybe one or two or three concept is basically left. Okay, so we have another 10 to 15 minutes, so I can try to cover those concepts. Okay, so and don't worry, maybe if one or two one concepts or maybe any concept is basically left, or maybe something which I basically think that yes, I can add this thing in this basically a lecture, or maybe uh, in this 7 days boot camp. So I try to basically add those things inside my notebook, and you guys can quit that notebook basically today's night itself. Okay, so you guys can access that notebook, and suppose if there is any extra thing you can find out in that notebook, and you are facing an issue that how this basically how this thing happens, so you guys can ask those query in a comment box, and you guys can ask those query in a tomorrow session also. There is no issue. Okay, so suppose if I try to create an array, np dot array. Okay. Okay, so this is an array. So this is what? This is just a 2D array. So flattening means what? Flattening means what? Flattening means you are trying to flatten your array. You are trying to flatten your array. So flattening means what? Whatever the dimension of your array. Okay, so what may be the possible dimension of array? Maybe a 2D, or maybe a 3D, or maybe a 5D. Any dimension. Okay. So whatever the dimension of array, you are trying to flatten your array in just a single dimension. Okay, so you are trying to flatten your array. So you are trying to basically flatten your array in a single dimension, means in a 1D. Okay, so as of now you are in a 2D. Okay, so the dimension of your array is nothing but a 2D. Now you are trying to reduce this 2D to 1D. Okay, so for that purpose you need to use an operation which is called a ravel. Okay, so ravel means what? Ravel means you are trying to flatten down your array. Okay, so Revel. Okay, so this is a meaning of a Revel operation. So okay, so this is a meaning of a Revel operation. Okay, so yes, you are able. I am able to basically flattening down flattening down the dimension of my array. Okay, so fine, guys. This is basically a meaning of a flattening operation. Now, if I basically show you one more important thing. Okay, so maybe if I just basically maybe if I just forgot this thing, or yeah, but this concept is basically important one. Okay, so that is nothing but I think uh, in our first session also I am talk about indexing and a slicing operation. Okay, so you can perform a indexing and a slicing operation inside basically inside this numpy also. Okay, so how you can basically perform a indexing and a slicing on operation. So np dot arrange, and suppose you just give a starting array and end array, fine. Okay, so in this single dimension, I think in a single dimension it is very easy for you to find out it is very easy for you to access any element. Okay, so it is very easy for you to access any element or a single element, or maybe if you want to maybe perform any slicing operation. Okay, so that is also fine. So if I want to access an element which is on a fifth position, so yes, I can access this element. Okay, and if I try to access maybe element between some range, okay, so maybe 3 to 10, so yes, I can access this thing. Nobody can stop me, and I think you already know about scaling concept. So you can access any element in a maybe a reverse direction. Okay, so there is no issue. Okay, so maybe if I want to access maybe some element from a -9 to a -2, and if you want this thing in a reverse direction, so you just need to apply basically -1 in this place. Okay, so why it is giving me so whether I'm having a -9 here or not. Okay, so 1 2 3 4 5 6 7 8 9, yes, I'm having this thing. Okay, so yeah, it is taking a wrong. Okay, how it is basically printing this way. Okay, so fine, leave it. I just try to look it at once and then again come on to this point. Okay, so but main fun, but the main thing which I need to tell you in this is that is like if you try to create a matrix. Okay, so inside that matrix, how you can basically how you can basically perform a indexing and a slicing operation. Okay, so maybe in this way. So maybe in this way. So 1 to 20, and then here you are trying to define basically a shape. Okay, so 4 5 cross 3. Okay, so fine. It is 5 cross 3. Now if I check my array, my basically matrix, so yes, I am able to check this thing. Now if I ask you to do try to perform a slicing operation, or try to perform maybe a indexing operation, or try to perform a single element, or try to basically access multiple elements at once, so yes, you can do this thing, because I think I already told you that how basically what is basically index value of this kind of matrix. Okay, so it is what it is, a 5 cross 4. So means you have a 5 element in a row column. Okay, so maybe in this way. So 15, 10, and 3, and 12, and 9. Okay, so 0, 1, 2, 3, and 4, and then 0, 1, 2, 3, 4. Okay, so if I ask you to access maybe any element, okay, so or maybe perform a slicing operation. Okay, so how you can perform a slicing operation? So suppose I just ask you to access this 4 element, this first 4 element. Okay, so what is basically a row of this? So 15, 3, and then 10 and 30. Okay, so I want to access this 4 element, 15 and 3, and then 10 and 30. So how I can access? So on the very first place, I need to define a row. Okay, so in a row wise, okay, so if I talk about basically a row, so in a row wise, it start from 0, okay, and you need to go till a 3, okay, because upper bound is always excluded. Okay, sorry, 2, okay, 0 and 1. So upper bound is always excluded. So in this way, I can basically take what I can take a row. Okay, so in this way, I can take a row. Okay, so 15 and 10. Now after the comma, you can basically access the columns. Okay, so for accessing the columns, I think the value of column is also same. So yes, I'm able to access 15, 3, 10, and 13. Okay, so you can access any element. Okay, so if you want to access any element in between 13, 14, 17, and 9, so yes, you can access in the same way. So 13, first value is 1. So you need to start from 1. You need to go till a 3. Okay, a row wise, and a column wise, this is also same. Okay, so in this way you can perform a slicing operation inside basically any kind of a matrix. Okay, so you can create a array, or you can create a matrix with the help of a NumPy, and then inside that you can perform a slicing operation, or you can perform a matrix operation very easily. So slicing and an indexing operation. Okay, so it is basically the same, just in a matrix. In case of a matrix, you need to be sure with basically a row and a column. Okay, so you need to be very sure with the with respect to a row and column, and the rest of the things are basically the same. Okay, so there is no issue in I think there is no issue in understanding the rest of the things. Fine. Okay, guys. So this is all this is all basically a different kinds of functions and different kind of concepts which is available inside a NumPy, and definitely this is not a limit of a NumPy. Okay, so NumPy can perform a lot many operations, but these are the operations which we use maybe regularly, or usually we use only this operations, and we actually need this concepts. Okay, so these concepts are basically a most used concept which I am trying to discuss in this 1.5 hours. Okay, and definitely I'm trying to if the notebook which I basically send you, so maybe in that notebook, maybe I am trying to discuss maybe one or two concepts more. Okay, and definitely definitely this is a limitless thing, but if you are able to basically understand this much of concept. Okay, so as a beginner, if you are able to understand this much of a concept also, so this is more than enough for you to perform any kind of a data analysis. Okay, so you can perform any kind of a data analysis if you are able to understand this much of a concepts. Okay, so this is all about from my side, guys. And anyone have so maybe I think today's session is about a library, so this is not a basic Python. So if anyone having any query, so yes, you guys can ask your query, you guys can ask your doubt. Okay, so if anyone having any query, so you can write in a chat box, or you can raise your hand, I can unmute you and you can ask your query. Okay, Seema. Okay, guys. Please don't do this. Don't try to annotate anything on notebook. If you have any doubt or query, so you guys can definitely ask. Okay, everyone is able to understand basically a NumPy. Any confusion or doubt, or maybe if you are able to understand, so you can also write this thing in a chat box that yes, you are able to understand. There is no issue. Okay, so someone. Okay, so there is two questions. So someone asked me that what is the difference between def and import. Okay, so def is basically a def is a keyword. Okay, so with the help of a def, with the help of that keyword, you are trying to define a function. Okay, so you are trying to create your own function with the help of a def keyword. Fine. And here this is def is not basically any kind and import is a kind of a thing with which you are trying to basically trying to import any library. Okay, so you are trying to basically take you are trying to use so whenever you need to use any kind of a library, so at that place you are using a import. Okay, so you are using a you are using a import thing. Okay, but def is a kind of a keyword. Okay, so there is no basically a relation between a def and an import. Okay, so def is a kind of a keyword through which you are trying to define your own function. Okay, so through which you are trying to define your own function. Fine. Can you explain cell number 125? Okay, cell number 125. Yeah, I think guys, yes, maybe I'm not basically okay. So if I trying to restart my kernel, okay, so let me do it. Okay, I just need to import NumPy again. Nothing more. Okay, I'm trying to basically just tell you about a slicing operation, and I think you know about a slicing operation that if you want to basically import a slice maybe a number of elements, a number of elements at once, so you need basically you need a basic slicing operation. Okay, so with the help of a slicing, you can basically do this kind of a job. But here there might be, I think, I'm not expecting maybe this thing. Okay, so whatever is going on in a cell number 125, so I'm not expecting this thing because I think I told you when I basically take an example in a string. Okay, so in a string, when I take an example of a reverse indexing. So in a indexing, if I try to basically I try to go from maybe one place. Oh, okay. So I think I get basically this concept. Okay, guys. Okay, okay, fine, fine, fine. Okay, so I try to. Okay, I'm basically making a mistake. Okay, so thank you, Arun, for asking this. Okay, so okay, so I now I realize my mistake. Okay, so I want to access from -9 to -2. Okay, so that is fine. If I want to access -2 from -2 to -9, then I need to basically give a step size as -1. Okay, but if I try to access from -9 to -2, so I can access an element between -9 and -2 only by adding +1. Okay, so -9 plus 1 is what? -8. Okay, -8 plus 1 is what? -7. Okay, so then only I can access a element between a -2 -9 and between -9 and -2. Okay, so okay, so now I basically realize, okay, so yes, this is giving me a correct answer. Okay, so I am just doing a foolish thing. Okay, so if I take a -2 to -9, then at that point of time I need basically a -1 as a step size. But here it is fine. Okay, so here my I need a step size as +1. Fine. Okay, Arun, if you take a first session, I think because of that, if you are getting a confusion, so I think here your confusion is clear, I think. Okay, so anyone else having any kind of a doubt or any kind of a query? Fine, guys, and everyone is able to understand. Sanjay and Arun, you guys are am I able to basically answer your query, or still there is some confusion? Okay, guys. So fine, no confusion. Okay, so thank you so much, guys. Try to connect on the same time tomorrow, and tomorrow I am going to discuss a very important thing. Okay, about a pandas. Okay, I am going to discuss about a pandas. So that is again a very important concept, and with the help of a pandas, we are doing a lot of data analysis. Okay, so pandas is basically one of the main concept inside basically much needed concept for making any kind of a data analysis. Okay, so try to don't try to miss basically a tomorrow session, and thank you so much. Okay, bye bye.